Telescoping and Divergence Test, Keeper 3.2. Alright, so a telescoping series is basically a series that when you work or you write the terms out of the series, terms start canceling out. So oftentimes you'll see like the second and the third term or the fourth and the fifth term, they'll cancel out, which will leave you with something that you can actually find the limit of, and you can determine exactly what the limit converges to. Alright, so first example, we want to figure out if the series converges or diverges, and if it does converge, we want to find the sum. So we have the sum from n going from 1 to infinity of 1 over n plus 1 minus 1 over n plus 2. So right here I see that I have two rational expressions, and not only are they two expressions, but they're being separated by a negative sign or a minus sign. So what I'm going to do is I'm going to go ahead and work out the terms of the series. Alright, so when I work them out, I get 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1/5, and so on, all the way until I get to 1 over n plus 1 minus 1 over n plus 2. And again, I just work that out by plugging in n equals 1, then n equals 2, then n equals 3, and so on into the series. Alright, so once I work the series out, I notice that every term is going to cancel except for the first term and the last term. So what I'm left with is 1/2 minus 1 over n plus 2. And so then I can go ahead and take the limit of that. And so I plug in infinity. The second term is going to go to 0, so I'm going to be left with just 1/2. This tells me that the series converges, and not only that, I know specifically it converges to 1/2. Alright, so example 2, very similar. This time though, they don't have something being separated by a minus sign. So what I'm going to do is I'm going to do partial fraction decomposition to figure out if it actually is being separated by a minus sign. And so I have a over 2k minus 1 plus b over 2k plus 1. I'm going to go ahead and get a common denominator, set it equal to my numerator. And so here I see that 2a plus 2b equals 0, and a minus b equals 2. Alright, so if I multiply the second equation by 2 and add the two equations together, I get 4a equals 4, or a equals 1. If a equals 1, then b must equal negative 1. Alright, so then if I rewrite that out, I end up with the sum from n equals 1 to infinity of a, which was 1 over 2k minus 1, minus b, or 1 over 2k plus 1. Alright, so then I'm going to write out the terms of my series. I notice again stuff is canceling out, so like I have 1 minus a third plus a third, so those thirds are going to cancel out. And then minus a fifth plus a fifth, those 1/5 are going to cancel out. And so basically I'm left with the limit of 1, because that's the only thing that didn't cancel, plus the last term, which didn't cancel, of 1 over 2k minus or plus 1. Alright, now if I take the limit of that, the negative 1 over 2k plus 1 is going to go to 0, and I'll be left with a 1 as my final answer. Alright, so the next test we want to look at is what we call the divergence test. The divergence test we use to determine if a series diverges. Please note that it does not determine whether it converges, okay? We can only tell for sure if it diverges using this test. And so basically what you want to do is you want to take the limit of your series, and you want to determine if it equals 0 or not. If it equals 0, then we know that we have to do some type of work to it or some other test to determine. But if it doesn't equal 0, I know for sure that that this series is going to diverge. So again, I'm looking to see if the limit equals 0 or not. If the limit equals 0, then I'm going to use some other type of test to determine whether it converges. If the limit doesn't equal 0, then I can use the divergence test to say it definitely diverges. Alright, so in our first example, we have the sum from 1 to infinity of 1 over n squared plus 1. I'm going to take the limit of that. And when I get the limit of that, I end up with 1 over infinity, which is 0. Alright, so again, because the limit equals 0, that tells me that I need to do some other test. I can't I can't rely on the divergence test because the divergence test is inconclusive. Remember, your divergence test cannot conclude convergence. It can only conclude divergence. So if it equals 0, you just have to use some other test, which we'll learn in a later lesson. All right, the next example, we have the sum from 1 to infinity of 3 into the 5th over into the 4th minus 2. I'm going to take the limit of that. And when I take the limit, because my numerator degree is bigger, I get infinity. Infinity does not equal 0. So now I can use my divergence test to say for sure the series diverges by the divergence test. All right, so here's another one. We have the sum from n equals 1 to infinity of 3 to the n over 2 to the n. First, I'm going to rewrite this so that I don't have like any indeterminate forms of L'Hopital's. And so I'm going to be left with 3 over 2 to the n. Now I can from here use the geoseries test, or I can use the divergence test, because if I take the limit of this and I plug in infinity, I'm going to be left with infinity. Infinity doesn't equal 0, so it diverges by the divergence test. Now again, you could have used your geoseries test, and because 3 over 2 is greater than 1, we also know that it diverges. All right, so example 5, we want to determine if it converges or diverges. I'm going to go ahead and try the divergence test, which I generally try first in every single series. I try that first because it's usually the easiest test to determine. So I'm going to take the limit. I notice that the limit of the top equals infinity. The limit of the bottom also equals infinity, so that means I have a L'Hopital situation. So using L'Hopital's, I'll take the derivative of the top, which is 1 over n, divided by the derivative of the bottom, which we get the chain rule, so we'd have 1 over ln n times 1 over n. Notice that your 1 over n's cancel out, and so you're left with 1 over ln n, which is just the same thing as ln n. When I plug in my limit of infinity, I get infinity. Infinity doesn't equal 0, so therefore I know it diverges by the divergence test.